You are sitting in a room where nothing appears to be moving. Your body is at rest relative to the floor. The walls are stable, and the objects around you behave as expected. Time feels like it advances forward, moment by moment, in a sequence you trust. Causes come before effects. The present feels like a boundary separating what has already happened from what has not yet occurred. But according to measurements that have already been made, that boundary may not exist in the way you assume. The equations used to describe space and time do not require a flowing present, and the observations used to confirm those equations do not reveal one. In the mathematical structure that best matches what we see, every moment you think of as future already has a defined position in space-time. Nothing in the data demands that it has not happened yet. The contradiction is not philosophical. It is observational. If time does not objectively move, and if all moments coexist within a fixed structure, then your experience of becoming is not a property of the universe. It is something else. The question is not whether this picture is true, but what it means that the universe works perfectly without the present you believe you are in. What follows is an examination of the measurements that led here and the implications they quietly impose. The assumption of now. You assume there is a present moment that exists objectively. This assumption feels unavoidable because your perception updates continuously. Yet no experiment in physics has ever identified a privileged moment called now. Every successful physical theory treats time as a coordinate, not a moving feature. The equations work whether you label an event as past, present, or future, because the labels do not appear in the mathematics at all. You do not usually question this assumption because it is reinforced by every ordinary action you take. You look at a clock and believe it displays the current time. You speak and expect your words to be heard after you finish forming them. You move your body and experience the movement as something that happens in sequence. The structure of experience itself suggests a dividing line between what has happened and what has not. This dividing line feels so fundamental that it is difficult to imagine reality without it. But physics does not recognize this division. When time appears in physical laws, it is represented as a variable that can take different values, just like position. There is no symbol for now. There is no operator that advances the universe from one moment to the next. The equations that describe motion, energy, and causality remain unchanged if you shift the time coordinate forward or backward. This symmetry is not an oversight. It is a measured feature of how the universe behaves. You might expect that observation would select a present moment. After all, experiments happen when they are performed, not before or after. But in physics, an experiment is simply an interaction between systems at a specific location in space-time. The theory does not treat that interaction as more real than any other. It is assigned coordinates and related to other events through causal structure. Nothing in the formalism elevates it into a universal reference point. This becomes more apparent when you consider observers in different states of motion. Two observers, moving relative to one another, do not agree on which distant events are happening now. This disagreement is not due to error or delay. It persists even after all signal travel times are accounted for. The measurements themselves demand it. If the present were an objective feature of the universe, all observers would be able to identify it consistently. They cannot. To preserve consistency with observation, physics abandons the idea of a global present. Instead, it treats all events as equally real, located within a four-dimensional structure. In this structure, what you call the present is simply the set of events that intersect your current physical state. Another observer, elsewhere or moving differently, intersects a different set. Neither intersection is privileged by the laws that govern the whole. This does not mean the theory denies your experience. It means the theory does not require it. The feeling that time passes is not contradicted by the equations, but it is not explained by them either. From the perspective of the mathematics, nothing is passing. There is no parameter that increases to carry the universe forward. There is only a fixed relationship between events. The absence of now is not a philosophical preference. It is the result of insisting that the same laws apply everywhere and everywhen. If you try to insert a moving present into the equations, you introduce an element that cannot be measured, cannot be synchronized, and cannot be reconciled across frames of reference. The theory becomes less accurate, not more. This creates a quiet but profound mismatch. Your most immediate certainty about reality is not reflected in its most successful description. The universe functions precisely as if every moment already exists, and as if the distinction between past, present, and future is something added locally, not something built into the structure itself. The question this leaves unresolved is not whether the present feels real. It clearly does. The unresolved issue is why a universe that does not contain an objective now nevertheless produces systems that experience one, and why that experience feels so fundamental when it is nowhere to be found in the measurements that describe the universe as a whole. Time as a dimension, you are accustomed to thinking of time as something different from space. Space can be traversed freely, while time appears to move you in only one direction. But in the models confirmed by relativity, time is inseparable from space. Together, they form space-time, a four-dimensional structure where events have fixed positions. Motion through this structure does not require a universal clock or a shared present. This distinction between space and time feels obvious because your experience treats them differently. You can choose to move left or right, forward or backward. You cannot choose to move earlier. Time seems to carry you, while space waits for you to act. This asymmetry feels built into reality itself. Yet when physicists attempted to describe motion in a way that matched observation at high speeds, this separation failed. Relativity begins with measurements, not intuitions. Experiments showed that the speed of light is the same for all observers, regardless of how they move. To make sense of this, space and time could no longer remain independent. Distances and durations had to adjust together. What one observer measures as space, another partially measures as time. The division depends on motion, not on the structure of the universe. In this framework, an event is defined by 4 numbers: 3 for location, 1 for time. None of these numbers is privileged. An event does not wait to occur. It simply has coordinates. The equations that govern physical processes relate these coordinates to one another, without implying that one slice of time is more real than another. The universe does not advance from one coordinate to the next. It already contains them all. This becomes clearer when you imagine tracing an object through space-time. Instead of thinking of the object as something that exists only in the present and then moves forward, relativity represents it as a continuous path. Every point along that path corresponds to a moment you would call past, present, or future. The path does not grow. It does not update. It is already complete. You might object that this is just a mathematical description, not a statement about reality. But the description produces predictions that match experiments with extreme precision. Time dilation, length contraction, and the relativity of simultaneity all emerge naturally from this 4-dimensional view. They have been measured repeatedly. The success of these predictions suggests that space-time is not a convenient fiction. It is the structure that best fits what is observed. Crucially, this structure does not require a universal clock. Each observer carries their own measure of time, and these measures cannot be globally synchronized. Attempts to define a single time that applies everywhere fail when tested. The universe does not provide a master timeline. It only provides relationships between events. This undermines the idea that time flows uniformly throughout reality. Flow would require a reference against which motion could be measured. In space-time, there is no such reference. There is no external time in which space-time itself evolves. Introducing one would move the problem rather than solve it, adding an extra dimension with no observational support. From this perspective, the difference you feel between space and time is not a property of the universe as a whole. It is a feature of how you are embedded within it. Your body follows a particular path through space-time, constrained by causality and energy. Along that path, you experience change. But the structure that contains the path does not share that experience. The unsettling implication is not that time is unreal, but that it is not what it seems. Time exists as a dimension, measurable and essential. Yet it does not behave like something that passes. The universe does not move through time. Instead, time is part of what the universe is. What remains unclear is how a static, four-dimensional structure gives rise to the persistent impression that something is always slipping away. Relativity removes simultaneity. You likely believe that two distant events can be said to happen at the same time. Measurements show this is not true. Observers moving relative to one another disagree on which events are simultaneous. This is not a limitation of perception, but a consequence of how space-time is structured. If simultaneity depends on motion, then a universal present cannot exist. This belief in shared simultaneity feels natural because your daily experience reinforces it. When you see lightning strike in the distance and hear thunder later, you instinctively separate the event itself from the delay in its signal. You assume that with perfect information, you could identify when the lightning truly happened. Physics shows that even with perfect information, this assumption fails once distance and motion are involved. Relativity demonstrates that simultaneity is not something hidden by signal delay. It is something that does not exist independently of an observer's state of motion. Two observers passing one another can assign different times to the same distant event, even after correcting for how long light takes to reach them. Both assignments are correct. There is no deeper timing beneath them. This result is not subtle. It is built directly into the equations and confirmed by experiment. The transformation that relates one observer's measurements to another's does not preserve simultaneity. Events that line up horizontally in one frame tilt in another. What one observer groups into a single moment, another spreads across time. No adjustment restores agreement. The reason lies in how time and space mix. In space-time, separating events into space and time is not absolute. The separation depends on how you move. When observers move differently, they slice space-time along different planes of simultaneity. Each slice is internally consistent, but no slice is preferred by the universe. If there were a true present, all observers would need to converge on it. Measurements would reveal a hidden alignment, a surface of space-time that represents what is really happening now. Decades of precise testing have found no trace of such a surface. The laws work without it, and attempts to add one introduce contradictions. You might think that this only applies to extreme speeds, far removed from ordinary life. But the effect exists at all velocities. It is simply too small to notice at human scales. The absence of simultaneity is not conditional. It is fundamental. The universe does not switch behavior when speeds become familiar. This has a direct consequence for how events are ordered. If two distant events are simultaneous for one observer, but not for another, then their classification as past, present, or future is not absolute. An event you consider already happened may be in another observer's future. This is not a paradox to be resolved. It is the expected outcome of the structure being described. Importantly, this does not allow causal contradictions. Events that can influence one another remain ordered in all frames. Light cones preserve causality. What changes is the ordering of events that cannot affect each other. These events have no fixed temporal relationship. The universe doesn't assign one. This distinction matters because it shows that time ordering is not universally defined, even where nothing observable depends on it. The present, if it existed, would have to apply everywhere, including to regions that cannot interact. Relativity shows that no such assignment is possible without breaking the consistency of the theory. The implication is quiet, but severe. The present moment cannot be a global feature of reality. It cannot extend across space. It cannot be shared by all observers. At best, it is a local construct, defined only along a particular path through space-time. What you experience as now is tied to your motion, your location, and your physical state. Another observer, elsewhere or moving differently, occupies a different now that does not align with yours. Neither is wrong. Neither is more real. The removal of simultaneity does not feel dramatic because it does not announce itself in daily life, but it quietly eliminates the idea that the universe is unfolding together. There is no single moment the universe is in. There are only relationships between events, laid out without a common temporal anchor. The discomfort comes not from speculation, but from accepting that the measurements leave no place for the present you thought you shared with everything else. The block that explains everything. To accommodate these observations, physics adopts a block-like view of space-time. All events are laid out within a single structure. Nothing enters or leaves it. This model predicts every tested relativistic effect with precision. It does so without requiring time to flow, advance, or update. The block does not change, yet change is observed within it. The appeal of this view is not philosophical elegance, but necessity. Once simultaneity is relative and time is inseparable from space, the idea of a universe that exists only in the present becomes untenable. A block description preserves consistency across all observers. Every event, regardless of when or where it occurs, is treated on equal footing. The laws apply everywhere without modification. In this picture, the universe is not something that happens. It is something that is. Events are not generated sequentially. They are positioned. A supernova, the formation of Earth, and the thought you are having now occupy different regions of the same structure. The theory does not require any of them to come into being. Their relationships are sufficient. You may be tempted to imagine the block as frozen, like a static snapshot. This is misleading. The block contains motion, interaction, and transformation. But these features are internal. Change is represented by differences between regions, not by the structure itself evolving. A river can exist entirely on a map without flowing across the paper. The flow is part of the map, not something that happens to it. This distinction matters because it removes the need for a moving present. If the croissant block contained only one moment at a time, something would need to update it. That update would require an external time parameter. No such parameter has been observed. The block avoids this by being complete. There is nothing outside it for time to flow within. The predictive success of this view is not abstract. It underlies every calculation involving relativistic motion. Particle accelerators rely on it. Satellite systems depend on it. Observations of distant galaxies match it. The equations that assume a fixed space-time continue to produce results that align with measurement, often to many decimal places. This success does not depend on whether the block feels intuitive. It depends on whether it matches reality. So far, it does. Attempts to modify it by reintroducing a global present either fail to reproduce known results or require untestable additions. The simpler explanation remains the one that removes becoming entirely. Within the block, objects are extended in time as well as space. A person is not a three-dimensional entity moving forward, but a four-dimensional pattern. Birth and death mark boundaries of that pattern. The experiences between them are variations along it. From within the pattern, these variations are lived sequentially. From the perspective of the block, they coexist. This raises an immediate discomfort. If all events exist, then nothing is truly open. The future is not waiting to be determined. It is already part of the structure. Physics does not soften this implication. It does not insert uncertainty to protect intuition. It simply describes relationships and leaves interpretation to you. Importantly, the block does not imply that events influence the past or violate causality. Causal structure is preserved. Light cones still constrain interaction. What changes is not what can affect what, but what exists at all. Existence is no longer tied to temporal arrival. You might wonder whether this picture is merely one interpretation among many. In practice, it is the interpretation that requires the fewest assumptions. It does not add invisible mechanisms to explain the passage of time. It accepts that the equations already work and asks what kind of universe they describe. The unease comes from the mismatch between explanation and experience. You feel time pass. The block does not. Yet the block explains everything that has been measured about time's behavior. This leaves a tension that cannot be resolved by adjusting the theory without breaking it. What remains unresolved is how a universe that never changes as a whole contains regions where change is unavoidable, and why consciousness finds itself aligned with those regions rather than with the structure that contains them. Motion, without becoming. Within this structure, objects do not move through time in the way you imagine. Their entire histories exist as extended paths. What you call motion is a relationship between different slices of that path. The feeling of progression is not represented anywhere in the model. The universe behaves consistently without it. You are used to thinking of motion as something that happens moment by moment. An object is here, then later it is there. Time, in this picture, acts like a conveyor, carrying the object forward. But in space-time, there is no conveyor. There are only trajectories. Each object is described by a continuous line that runs from one region of space-time to another. The line does not advance. It is already there. This line is often called a world line. It contains every event associated with the object, its formation, its interactions, its eventual disintegration. Nothing needs to be added to it. When physicists calculate motion, they do not simulate the object moving forward in time. They relate different points along this world line and determine how they are connected by the laws of physics. From your perspective, you occupy one point on your own world line. Nearby points contain records of earlier states and conditions that give rise to later ones. The sense of motion arises because each point includes information about adjacent points. Your brain compares these records and constructs continuity. But this construction does not appear in the space-time description itself. In the block view, there is no mechanism that pushes objects along their paths. The path is not something the object follows. It is what the object is. Removing the idea of becoming simplifies the theory without reducing its explanatory power. All predictions remain intact. The equations do not change. This becomes clearer when considering relativistic effects. Two observers can disagree about the rate at which an object moves through time. One observer sees the object's clock run slower than another's. Both measurements are correct. There is no underlying true rate of passage to appeal to. The object's history simply has a certain shape in space-time, and different observers project that shape differently. If motion required an objective flow of time, these disagreements would signal a problem. Instead, they confirm the model. Time dilation is not a malfunction. It is evidence that motion through time is not a fundamental process. It is a geometric relationship. You might feel that this description strips motion of its reality. But nothing observable is lost. Objects still collide. Processes still unfold. Energy is transferred. All of this is encoded in the structure of space-time. What is absent is an extra layer of explanation that was never measured. The feeling of progression remains unexplained by the physics because it is not required to explain anything else. The universe does not slow down or speed up its passage. It does not hesitate or accelerate. There is no reference against which such changes could be detected. This absence becomes more troubling when you consider that becoming feels central to existence. You remember yesterday. You anticipate tomorrow. You experience effort, delay, and waiting. Yet none of these require time itself to move. They require ordered states with asymmetrical relationships. The block contains these asymmetries without invoking passage. In this framework, nothing is in the process of happening. Events are located relative to one another, not arriving. The universe does not transition from incomplete to complete. It is not building itself. It simply satisfies the constraints imposed by its laws everywhere. This leads to a subtle shift in how motion is understood. Motion is not something that occurs to an object. It is a comparison between different parts of its space-time extent. Change is real, but it is internal. It does not imply an external progression. The unresolved tension is that you are aware of movement in a way that feels immediate and undeniable. The model that describes movement with precision does not contain that immediacy. It describes relationships that are timeless. What remains unclear is why your experience aligns with one narrow slice of a world line rather than with the full structure that defines it. Observation does not select a moment. You might expect measurement to rescue the present. After all, you observe things now. But observation in physics is simply an interaction between systems. It does not mark a moment as special. Experiments occur at coordinates like any other event. The theory does not elevate the act of observing into a generator of time. This expectation comes from how observation feels from the inside. When you look at an object, its state seems to become definite. When you read a measurement, uncertainty appears to resolve. It is tempting to think that observation pulls reality into the present, that something about being measured causes events to become real. Physics does not support this interpretation. In the formal description, an observation is a physical process governed by the same laws as any other interaction. A detector absorbs energy. A particle leaves a trace. A system becomes correlated with another system. These processes occur at specific locations in space-time. They do not initiate a universal update. They do not bring the rest of the universe into alignment with a now. This becomes clear in quantum experiments that are often misunderstood as privileging the observer. Even in these cases, the mathematics does not assign a special role to consciousness or to the act of looking. Measurement outcomes are recorded through physical interactions. The equations describe how probabilities relate across events, not how reality waits for attention. Crucially, observation itself is not instantaneous. It has duration, structure, and causal history. A measurement involves preparation, interaction, and recording. Each of these stages occupies its own region of space-time. There is no single moment at which observation happens. The idea of a sharp now is not supported even at the level of an experiment. If observation selected the present, then different observers would be forced into agreement about which events exist. This does not occur. Observers in relative motion still disagree about simultaneity even after exchanging measurement results. The act of observing does not collapse space-time into a shared moment. It preserves the same relativistic structure as everything else. You might argue that observation creates facts, even if it does not create time. But facts, in physics, are simply correlations between events. A recorded measurement is a relationship between the system measured and the recording device. That relationship exists at particular coordinates. It does not propagate backward or forward to define a present elsewhere. This interpretation is reinforced by delayed choice experiments, where the decision of how to measure a system can be made after the system has already interacted with a detector. The results remain consistent without requiring any retroactive selection of reality. The space-time description accounts for all outcomes without invoking a moving present that reacts to observation. The absence of a privileged moment is not a flaw in the theory. It is a consequence of its consistency. If observation created a now, that now would need to be synchronized across space. No mechanism exists for such synchronization that does not violate observed relativistic effects. The universe does not pause to wait for measurement. Instead, observation is something that happens within space-time, not something that defines it. Your experience of seeing, hearing, and measuring is part of the block, not an operation performed on it. The feeling that observation anchors you in the present arises because your sensory systems process information locally and sequentially, not because the universe responds to being observed. This distinction matters because it removes one of the last intuitions that might protect the present. If even observation fails to single out a moment, then nothing in the measured universe does. There is no physical event that can be identified as the transition point between unreal and real. What remains is a universe where observation reveals relationships that already exist. You do not summon events into being by witnessing them. You intersect them. The unsettling implication is that the present you experience is not something you enter by observing, but something constructed by the way your physical systems are arranged within space-time. The arrow, without a flow, you know that time seems to have a direction. Entropy increases. Systems evolve toward disorder. This arrow is real and measurable, but it does not imply a moving present. It describes asymmetry across the block, not motion through it. The direction exists without anything advancing along it. This arrow feels like the strongest evidence that time flows. You see glasses shatter, but never reassemble. Heat spreads from hot objects to cold ones, and not the reverse. You remember the past, but not the future. These patterns appear to demand a forward-moving time that carries systems from order to disorder. Physics agrees that the patterns are real. It disagrees about what they require. The increase of entropy is a statistical statement, not a dynamic one. It describes how many microscopic arrangements correspond to a given macroscopic state. Ordered states are rare. Disordered states are common. When a system transitions from one state to another, it is overwhelmingly likely to move toward states that can be realized in more ways. This likelihood does not depend on a flowing present. It depends on counting possibilities. In the block view, regions of space-time differ in entropy. Early regions contain systems in relatively constrained configurations. Later regions contain systems with fewer constraints. This gradient defines an arrow. But the arrow is a pattern embedded in the structure, not a process that unfolds. It does not require time to move any more than a slope requires a traveler to exist. This distinction becomes clearer when you consider that the fundamental laws governing microscopic interactions are largely time-symmetric. They do not prefer a direction. If you reverse the order of events at that level, the equations still hold. The arrow emerges not from the laws themselves, but from the boundary conditions imposed on the universe as a whole. Those boundary conditions are observationally supported. The early universe appears to have been in an unusually low entropy state. This is not inferred from philosophy, but from measurements of cosmic background radiation and large-scale structure. The arrow of time points away from that state in both temporal directions. The asymmetry is real, but it is global, not dynamic. From within the block, this means that different temporal regions have different statistical properties. Systems embedded in those regions evolve in ways that reflect those properties. An observer located in a low entropy region will experience increasing entropy in one direction along their world line. That direction becomes their future. The opposite direction becomes their past. Nothing in this description requires the universe to advance. The arrow does not sweep forward. It simply exists as a feature of the space-time layout. Just as a gradient in temperature can exist across space without heat moving everywhere at once, an entropy gradient can exist across time without time itself flowing. This challenges the intuition that the arrow and the flow are the same thing. They are not. The arrow explains why processes are irreversible and why memory works the way it does. It does not explain why you feel carried from one moment to the next. That feeling is not encoded in the entropy gradient. In fact, The arrow can be defined without reference to any observer. It is a statement about distributions of states. Flow, by contrast, is inseparable from experience. The equations contain the arrow. They do not contain the flow. This separation becomes uncomfortable because it removes one of the last physical anchors for becoming. If entropy increases without time passing, then direction does not imply motion. There can be a before and after without a transition between them. You still experience waiting. You still experience decay and growth. But these experiences correspond to asymmetries along your world line, not to a universal advance. The block contains all stages of these processes. Your location within it determines which stage you experience. The unresolved tension is that the arrow explains why events are ordered, but not why they are encountered sequentially. It accounts for irreversibility without accounting for passage. The universe provides direction without movement. What remains unexplained is why that direction feels like something is happening, when nothing in the structure itself ever does. Causality in a fixed structure. Causes precede effects, but precedence does not require becoming. In space-time, causal relationships are geometric. One event lies within the light cone of another. The order is fixed, but nothing flows from one to the next. The structure contains the relationship without enacting it. You are accustomed to thinking of causality as a process. A cause happens, then something later responds to it. This sequence feels active, as if reality moves from one state into another. Physics does not describe causality this way. It describes constraints on how events can be arranged. The relationship is static, even though its consequences feel dynamic. In space-time, every event has a region it can influence, and a region that can influence it. These regions are defined by the speed of light. If one event lies within another's future light cone, then it can be affected by it. If it lies outside, it cannot. This rule does not evolve. It applies everywhere, always, without reference to a present moment. Causal order is therefore not something that unfolds. It is something that exists. Events are positioned such that some are connected and others are not. The universe does not wait for a cause to produce its effect. Both are already located within the structure, linked by allowable paths. This becomes clearer when you consider that different observers can disagree about the temporal ordering of events that are not causally connected. For these events, there is no objective before or after. Yet causality remains intact. No observer ever sees an effect occur before its cause if the two can influence one another. The geometry preserves this order without invoking a flowing time. You might expect that causality requires a mechanism that carries influence forward. Physics does not supply one. It specifies limits, not carriers. Fields and interactions are described by equations that relate values across space-time. They do not depict signals being pushed through a present. They describe correlations between events at different coordinates. This absence is not accidental. Introducing a moving present that transmits causation would require an additional structure layered on top of space-time. That structure would need to be detectable. No such detection has occurred. The existing framework explains all known causal phenomena without it. In the block view, causation is a pattern, not an action. A cracked glass and the impact that cracked it are related within space-time. One is inside the future light cone of the other. The relationship holds whether or not you imagine the crack forming over time. The model does not require the crack to emerge. It only requires that both events exist in the correct relation. From within the system, this feels incomplete. You experience effort leading to outcome. You act and later observe consequences. But this experience corresponds to your position along a chain of events, not to the chain being created. The chain does not assemble itself as you move. It is already assembled. This does not undermine responsibility or agency in the physical description. Decisions are events with causes and effects like any other. They occupy positions in space-time and influence what lies within their future light cones. What changes is not whether causes matter, but whether they require time to pass to matter. The fixed structure does not imply that effects exist without causes. It implies that causes and effects coexist within a constrained arrangement. The necessity of the cause is preserved. The necessity of becoming is not. This distinction is subtle because your experience of causality is inseparable from memory. You remember causes and anticipate effects. These records create the impression of a forward march. But the geometry of space-time already encodes the order. Memory does not generate it. It reflects it locally. The unsettling implication is that causality does not push reality forward. It does not drive events into existence. It simply describes which events are connected. The universe does not progress from cause to effect. It contains both, arranged such that the connection is never violated. What remains unresolved is why this static arrangement feels active from the inside, and why being located at one end of a causal chain gives rise to the sensation that something is unfolding, when the structure that contains the chain never changes at all. The illusion of passage. Your experience suggests that moments arrive and depart. Physics does not support this. There is no parameter in the equations that increases to mark the arrival of now. The sense of passage must therefore arise from processes inside the block, not from the block itself. This places your most basic intuition outside the fundamental description of reality. You feel time pass in a way that seems undeniable. You wait for a sound to finish. You notice the delay between a thought and an action. You experience anticipation and relief. These sensations create the impression that reality is continuously updating, replacing one moment with the next. Yet when you look for this update mechanism in physics, nothing corresponds to it. The laws that govern motion and interaction do not contain a variable that represents passage. Time appears as a coordinate, not as a process. You can differentiate with respect to it, compare intervals along it, and relate events across it, but you cannot point to anything that makes it move. There is no equation that says now increases. If passage were a physical phenomenon, it would leave traces. Different systems might experience it at different rates. Conditions could alter it. Experiments could detect it. None do. Clocks measure intervals between events. They do not measure time itself flowing. They register changes in physical systems that are arranged to be regular. The regularity is what is measured, not the passage. This suggests that the feeling of passage is generated by something local. It arises from how certain systems are structured within space-time. Your nervous system is one such system. It records information asymmetrically. It retains traces of previous states and uses them to predict later ones. This asymmetry creates a sense of direction and progression. Importantly, this does not require time to move. It requires ordered states with memory. A sequence of brain states, each containing records of earlier states, will experience continuity, even if all those states coexist in the block. From the outside, they are simply arranged. From the inside, they feel sequential. This distinction explains why passage feels immediate, but resists formal description. It is not a property of space-time. It is a feature of certain trajectories through it. Most physical systems do not experience time passing. A rock does not. A radioactive atom does not. Only systems that store and compare records generate the impression of flow. You might object that this reduces passage to an illusion. Physics does not label it that way. It simply does not include it. The feeling is real in the sense that it is experienced. It is not real in the sense that it corresponds to an external process. Both can be true without contradiction. This becomes more unsettling when you realize that the absence of passage does not disrupt prediction or explanation. The block model accounts for everything that has been measured without invoking a moving now. Removing passage does not weaken the theory. It strengthens it by eliminating an unmeasured assumption. What remains is a divide between description and experience. The universe, as described by its most successful theories, does not advance. It contains. Within it, there exist systems that experience advance. The theories explain the container, not the experience. This divide cannot be closed by adding passage to the equations. Doing so would introduce an element that has no observable effect. It would sit outside measurement, immune to confirmation or falsification. Physics avoids such additions not because they are impossible, but because they explain nothing. The implication is not that your experience is mistaken. It is that it is not fundamental. The sense of passage is something that happens within the universe, not something the universe does. It belongs to certain arrangements of matter, not to space-time itself. What remains unresolved is why this arrangement feels so central to existence. If the universe does not move through time, but you feel as though you do, then your experience of reality is anchored to a feature that the universe itself does not possess. The discomfort comes from recognizing that what feels most immediate may be the least reflected in the structure that contains it. Memory as a physical trace. You remember the past and not the future. This feels like evidence that the past is fixed and the future open. In reality, memory is a physical record embedded in a system. Records exist in some regions of space-time and not others. This asymmetry does not require the future to be unreal, only unrecorded at your location. Memory feels like a window into what has already happened. You can recall earlier events, replay conversations, and reconstruct sequences. The absence of equivalent access to the future makes it seem incomplete, as though it does not yet exist. Physics offers a different explanation. It treats memory as a particular arrangement of matter, governed by the same laws as any other physical structure. A memory is not a timestamp pulled from time itself. It is a trace left by interaction. Neurons change their connections. Molecules settle into stable configurations. Physical systems record correlations with earlier states. These records persist because entropy increases, making certain configurations more likely to remain than to spontaneously reverse. The existence of memory depends on this asymmetry, not on the non-existence of the future. In space-time terms, a memory is simply an event that contains information about another event. The two are related causally. The earlier event lies within the past light cone of the memory. This relationship does not imply that the remembered event is more real than events outside that cone. It only implies that information about it can be present. You do not remember the future because there are no physical records of it where you are. That absence is local, not global. In other regions of space-time, events you call future already exist. They contain their own records of what you would call earlier states. From their perspective, your present is part of their past. This symmetry is difficult to accept because you experience only one direction of access. But access is not existence. Telescopes let you see distant galaxies as they were billions of years ago. That does not mean the galaxies stopped existing after emitting that light. Your inability to observe something does not determine its reality. Memory also creates the impression of sequence. Each remembered state is compared to the current one, producing a sense of progression. But the progression is internal. It is a comparison between stored records and present conditions along your world line. The block contains both the memory and the event remembered. It does not prioritize one. This understanding explains why memory is fallible and selective. Records degrade. They are influenced by later events. If memory were a direct connection to the past, such distortions would be difficult to explain. As a physical trace, distortion is expected. It is subject to noise, decay, and interference. The same reasoning applies to written records, photographs, and fossils. These are not pieces of the past preserved in time. They are present configurations of matter that carry information about other regions of space-time. Their existence depends on causal chains, not on temporal privilege. This reframing removes the idea that the past is special because it is remembered. It is special because it has left traces. The future has not left traces here because information cannot propagate backward along light cones. This limitation enforces the asymmetry of memory without requiring an asymmetry of existence. You might suspect that this interpretation empties memory of its meaning. It does not. It grounds it. Memory becomes something that can be studied, measured, and explained. It no longer needs the past to be ontologically distinct from the future. It needs only physical processes that preserve information in one direction. The unsettling implication is that your certainty about the past is not a guarantee of its privileged reality. It is a reflection of your position in space-time and the records available there. The future is not absent. It is simply not recorded yet from where you are. What remains unresolved is why consciousness is tied to systems that access records in only one direction, and why that limitation feels like a fundamental feature of time rather than a consequence of physical constraints that do not apply to the universe as a whole. Prediction without indeterminacy. You often hear that quantum mechanics restores openness to the future. But even quantum theories can be formulated within a block framework. Probabilities describe distributions across the structure, not events waiting to happen. Indeterminacy does not imply incompleteness in time, only limits in prediction. Quantum mechanics is often presented as a break from determinism. Outcomes are said to be undecided until measured. The future, in this view, remains genuinely open. This interpretation feels like a corrective to the block universe, reintroducing becoming at a fundamental level. But this feeling depends on how probability is understood, not on what the theory requires. In the mathematical formalism, quantum mechanics does not describe events coming into existence. It describes the relationships between possible outcomes across space-time. The wave function evolves according to precise equations. Measurement does not halt this evolution or insert a present moment. It produces correlations between systems at specific coordinates. Probabilities in quantum mechanics do not point forward in time. They are not statements about what will happen next. They are statements about the structure of outcomes across the theory. A probability distribution applies to an entire experimental setup, including preparation, interaction, and recording. All of these are events within space-time, not steps in a temporal unfolding. This becomes clearer in interpretations that remove collapse entirely. In these formulations, all outcomes exist as part of the structure. Probability reflects how these outcomes are weighted, not whether they occur. The block framework accommodates this naturally. The universe does not branch as time passes. The branches are already present as part of the description, even in interpretations that include collapse. The collapse is not a physical wave moving through time. It is an update to a description based on new information. The underlying events remain fixed. What changes is the observer's knowledge of how they are related. This distinction matters because it separates uncertainty from ontology. You cannot predict the outcome of a quantum measurement with certainty. But this does not mean the outcome is not already part of space-time. It means you lack access to the information needed to locate which outcome corresponds to your future observations. prediction fails without implying that reality is incomplete. This distinction is familiar in classical contexts. You cannot predict the exact motion of every molecule in a gas, but their trajectories still exist. Probability reflects ignorance or practical limitation, not indeterminacy in existence. Quantum mechanics extends this limitation, but it does not overturn the block. Importantly, quantum experiments do not reveal a preferred moment when possibilities become actual. Measurements occur over intervals. Detectors register signals gradually. Records are formed through physical processes with duration. There is no sharp boundary where the future becomes real. Delayed choice and entanglement experiments reinforce this point. Correlations appear between events that are space-like, separated, or temporally reordered by different observers. The outcomes remain consistent without invoking a moving present that resolves them. The structure holds without updating. If quantum mechanics required an open future, it would conflict with relativity. An outcome becoming real at one moment would need to become real everywhere at once. No mechanism exists for such global synchronization. The continued success of relativistic quantum theories suggests that no such mechanism is needed. The unease comes from conflating unpredictability with openness. They are not the same. You can be uncertain about something that is already fixed. Lack of prediction does not imply lack of existence. Physics consistently chooses the weaker claim because it is sufficient. Within the block, quantum probabilities describe patterns across space-time. They tell you how often certain configurations appear relative to others. They do not describe reality waiting to decide. The universe does not hesitate. What remains unresolved is why uncertainty feels like possibility. From within a limited perspective, not knowing what lies ahead feels like the future is unwritten. From the perspective of the theory, it is simply unknown to you. The discomfort arises from recognizing that quantum mechanics, often invoked to rescue becoming, quietly fits into a universe where nothing is ever added, only revealed. The universe. Without updating, there is no evidence the universe updates itself frame by frame. No experiment has detected a global tick. Field equations relate regions of space-time to one another without reference to a current state. The universe does not compute forward. It already satisfies the equations everywhere. You may picture reality as something that refreshes continuously, like an image redrawn at every instant. This intuition comes from machines you interact with and from the way your perception updates. physics does not support this picture. Nowhere in its successful theories does a mechanism appear that advances the universe from one state to the next. The equations that describe fundamental fields do not evolve a present moment into a future one. They specify relationships between values at different coordinates. Solutions to these equations describe entire configurations of space-time at once. When physicists solve them, they do not step through time. They determine structures that satisfy the equations globally. If the universe were updating, there would need to be something that performs the update. A rule that applies now and produces what comes next. This rule would have to operate in time, which would require a second time parameter. No observation suggests such a parameter exists. Introducing one would add complexity without evidence. Instead, the equations treat all regions of space-time symmetrically. There is no privileged slice that represents the current state. Boundary conditions constrain the structure, but they do not initiate a process. Once specified, the entire configuration is fixed. This is not an abstract claim. It is reflected in how predictions are made. To predict an event, physicists do not advance the universe forward. They calculate relationships between events. The predictions remain valid regardless of where you place the present in the calculation. The equations do not care. Even numerical simulations, which appear to step through time, do so only as a computational convenience. The simulation updates because the computer requires it, not because the universe does. The underlying model assumes a completed structure. The stepping is an artifact of how humans solve equations, not of what the equations describe. You might expect the absence of updating to conflict with change. It does not. Change is encoded as variation across the structure. Different regions contain different configurations. The laws relate these differences without implying that one causes the other to come into existence. This becomes especially clear in relativistic contexts, where different observers disagree on what constitutes a slice of the universe at a given time. If the universe were updating, these slices would need to align. They do not. Each observer's description is equally valid, suggesting there is no underlying update cycle. The lack of a global tick also explains why time dilation occurs. If clocks measured an advancing present, their rates would need to reflect how fast time itself flows. Instead, clocks measure local processes. Differences in their readings reflect differences in space-time geometry, not in passage. The universe, as described, is not executing instructions. It is not processing information sequentially. It is constrained by equations that are satisfied everywhere. Nothing waits for permission to exist. This undermines the idea that the future is generated by computation. There is no cosmic processor assembling reality step by step. The notion feels natural because human-made systems work this way. The universe does not. What remains is a structure that does not need to be refreshed to remain consistent. Events do not appear because time has advanced. They appear in the equations because their relationships require them. The unsettling implication is that reality does not happen. It does not update, recalculate, or move forward. It simply is configured in a way that allows for local change without global progression. What remains unresolved is why you experience anticipation and delay in a universe that does not wait. If the structure is complete, the feeling that something is about to occur cannot reflect the universe preparing to update. It must reflect the limitations of a system embedded in a structure that does not share its sense of sequence. Scale does not restore the present. You might suspect this picture breaks down at human scales. It does not. Atomic clocks on airplanes run differently than those on the ground, exactly as predicted. GPS satellites must correct for relativistic time offsets to function. These technologies work because there is no universal now to return to. It is tempting to believe that relativity only matters in extreme environments. Near light speed, near black holes, far from everyday experience. But the effects that remove a universal present operate everywhere. They are small at human scales, not absent. Precision has simply become good enough to reveal them. Atomic clocks provide a direct demonstration. Identical clocks, synchronized and then separated, do not remain synchronized when brought back together if they followed different paths. The difference is not due to malfunction or environmental interference. It is due to how time is structured in space-time. Each clock measures proper time along its own path. There is no deeper time they can both appeal to. This result has been measured repeatedly in aircraft, in satellites, and on the ground. The discrepancies match relativistic predictions exactly. If there were a hidden universal present, these differences would be errors. They are not. They are essential to the theory's accuracy. Global positioning systems rely on this fact. Satellites orbiting Earth experience both special and general relativistic time shifts. Their clocks tick at different rates than clocks on the surface. If engineers treated time as universal, the system would drift by kilometers each day. It functions only because time is local and relative. These systems do not correct clocks to a true now. They coordinate between different time standards. They reconcile differences without assuming an underlying simultaneity. The absence of a universal present is not a philosophical conclusion here. It is a practical constraint. This shows that the block picture is not confined to abstract theory. It governs technologies you depend on. The universe does not behave as if there is a single time flowing everywhere, even at walking speeds and everyday distances. You might still suspect that these are minor corrections layered on top of an otherwise classical picture. Physics does not support that interpretation. The corrections are not optional. They are not approximations to a deeper truth. They are the truth revealed with sufficient precision. As measurements improve, the classical notion of a shared now recedes further. There is no scale at which it reappears as an exact feature. It remains an approximation born of limited resolution, not a fundamental property waiting beneath. This challenges the idea that human experience defines the structure of reality. Your senses evolved to navigate a narrow range of conditions. They smooth over differences that matter at higher precision. The universe does not adjust itself to match those limitations. From the perspective of space-time, human-scale processes are not special. They occupy regions like any other. The same rules apply to neurons firing and to stars orbiting galaxies. Scale changes magnitude, not principle. This is why no experiment, regardless of scale, has uncovered a privileged present. Increasing precision reveals structure, not flow. It exposes discrepancies that only make sense if time is not shared. The persistence of the present in experience does not imply its existence in nature. It implies that certain effects are usually negligible. When they cease to be negligible, the assumption fails. The unsettling implication is that the present survives in intuition only because it is a convenient approximation. It is not restored by scale. It is erased by accuracy. What remains unresolved is why approximation feels fundamental. If the universe never had a shared now, then the sense that everything is happening together is a constructed impression. It works well enough to survive in daily life, but it dissolves as soon as reality is measured carefully enough to reveal what it never included in the first place. The local construction of experience. Your experience of time arises locally. Neural processes compare records, update internal states, and generate continuity. These processes are physical events like any other. They do not require the rest of space-time to be incomplete. They occur at specific coordinates within it. What you call the passage of time is produced by how these processes are arranged. The brain does not perceive space-time as a whole. It operates within a narrow region, processing signals that arrive in a particular order. That order is determined by causal structure, not by a moving present. The sensation of now is the result of active comparison, not global synchronization. At any given moment, your brain contains traces of earlier states. These traces are physical records, altered synapses, chemical gradients, stored patterns. When current input is compared against these records, a sense of continuity emerges. The comparison creates directionality. It distinguishes what is remembered from what is anticipated. But this distinction is internal, not cosmic. Nothing in this process requires time itself to flow. The brain does not detect a universal clock. It infers sequence from structure. Events that leave records are treated as past. Events that have not yet left records are treated as future. This classification is a feature of information processing, not a property of space-time. The feeling that moments arrive one after another is a model constructed by the nervous system. It is useful. It compresses vast causal complexity into a manageable narrative. But usefulness does not imply fundamentality. The brain evolved to guide action, not to reveal ontology. Importantly, these neural processes are themselves extended in space-time. Each firing pattern, each update, each comparison exists as part of a larger structure. From the block perspective, your entire stream of experience is an extended object, not something that unfolds into being. The feeling of unfolding is contained within that object. This resolves a common confusion. If all moments exist, why do you only experience one? The answer is that experience is not a viewpoint hovering above time. It is a physical process embedded in it. Each experience corresponds to a specific region. There is no mechanism by which a system could experience all regions at once. You do not move along the block. You are a pattern within it. Different parts of that pattern include different experiential states. Each state contains memories of others, but none has access to the whole. The limitation feels like motion because memory is asymmetric. This asymmetry does not require a metaphysical distinction between past and future. It arises from thermodynamics, causality, and information storage. Records are formed in one direction because entropy gradients make them stable in that direction. The brain exploits this stability to build coherent narratives. Seen this way, the present is not a slice of the universe. It is a local computational achievement. It is the momentary integration window of a system trying to maintain coherence. Different systems will have different windows. There is no requirement that they align. This explains why the present feels immediate and undeniable while remaining absent from physics. Physics describes the structure in which experiences occur. Experience describes how a subsystem navigates that structure. Confusing the two leads to the illusion that the universe must mirror perception. The deeper implication is unsettling. The flow of time is not something happening to the universe. It is something the universe allows certain systems to model internally. Your sense of becoming is real as an experience, but it is not a feature the cosmos needs in order to exist. When physics removes the present, it does not erase experience. It relocates it. The passage you feel is not denied. It is explained as a local phenomenon, generated by matter arranged in a particular way, at a particular place in space-time. The universe does not wait for you to arrive at a moment. It contains the process by which arriving feels unavoidable. Freedom inside a fixed whole. The idea that the future already exists feels incompatible with choice. Yet the physics does not remove decision-making processes. It places them as structures within space-time. Choices occur at defined locations, with defined causes and effects. Their existence does not depend on openness elsewhere. You are accustomed to thinking that freedom requires an unwritten future. If the outcome is already there, it seems as though deliberation becomes meaningless. But this conclusion assumes that choices must reach forward into nothingness to be real. Physics does not support that assumption. It treats decision-making as a physical process, not as an exception to structure. When you decide, neural activity unfolds according to prior conditions. Sensory input, internal states, and memory interact. Competing possibilities are evaluated. One pattern stabilizes, another does not. This process has duration, consumes energy, and leaves records. It is no less real because it occupies a region of space-time rather than creating one. From within the process, the outcome is not known. Uncertainty is genuine at that location. Multiple futures are represented internally as competing models. The fact that only one is realized does not negate the reality of evaluation. It describes how evaluation resolves. In the block view, all of this exists as structure. The deliberation exists. The outcome exists. The causal link between them exists. What is absent is a global mechanism that waits to see what you will do. The universe does not pause at decision points. It contains them. This reframes the meaning of freedom. Freedom is not the ability to alter the block. It is the presence of mechanisms that generate behavior based on internal evaluation, rather than external constraint. A system is free to the extent that its actions are produced by its own structure. Nothing in physics requires that such systems be embedded in an incomplete universe. A chess game recorded move by move is fixed on the page. Yet within the game, choices were made. Strategies were weighed. Errors occurred. Fixity of the record does not erase the reality of the play. The same applies here. The existence of your future does not render your reasoning inert. The reasoning is part of why that future has the form it does. Removing the idea of a changing present does not remove causation. It removes a metaphor. This is difficult to accept because it conflicts with how agency feels. You experience yourself as standing at a branching point, selecting one path from many. That experience corresponds to internal models, not to global indeterminacy. The branching is representational. Physics does not claim that alternatives were equally real, and then one was selected by an external hand. It describes how certain configurations lead to others. If your internal state includes uncertainty, that uncertainty is real at that coordinate. It does not need to propagate outward into the structure as a whole. Importantly, the block view does not imply coercion. Nothing forces a decision from outside the system. The causes of your choices include who you are, what you know, and how you process information. These are not negated by their placement in space-time. What is lost is a comforting picture in which the future waits, undefined, for your arrival. What remains is a more austere one, in which your arrival is itself a defined phenomenon. The universe does not consult you. It includes you. This distinction matters. If freedom required the universe to be unfinished, it would be incompatible with measurement. But freedom defined as internal causation is compatible with everything observed. It does not require exceptions. It requires structure. The unsettling implication is that your sense of authorship does not come from altering reality's course. It comes from being the mechanism through which that course takes a particular shape. The future is not open around you. It is open within you, as computation, evaluation, and uncertainty occurring exactly where you are. Your choices do not carve time forward. They occupy it. The absence of a universal clock, no reference frame can claim to represent the true present. Attempts to define one fail experimentally. Time dilation is symmetric and reciprocal. Without a preferred clock, there is no mechanism to single out which slice of space-time is real. You are used to imagining that somewhere beneath appearances, there must be a master clock, a reference that tells the universe what time it is. This intuition feels natural because clocks surround you. They agree closely. They give the impression of synchronization, but that agreement is local, contingent, and fragile. Relativity shows that every clock measures its own proper time. The rate at which it ticks depends on its motion and the gravitational field it occupies. Two clocks following different paths through space-time will generally disagree when reunited. This is not because one malfunctioned. It is because time itself is path-dependent. Crucially, this disagreement is not an illusion that disappears at higher precision. It grows more pronounced as measurements improve. Atomic clocks confirm it routinely. The equations that predict it do not allow one clock to be corrected to reveal the true time. There is no hidden standard they are deviating from. You might expect symmetry to break somewhere. Perhaps acceleration picks out a preferred frame. Perhaps cosmology does. But no such frame has been found. Even the cosmic microwave background, which defines a convenient rest frame for large-scale structure, does not reinstate a universal present. It is a feature of matter distribution, not of time itself. Without a privileged clock, simultaneity becomes negotiable. Different observers slice space-time differently. Each slicing is internally consistent. None can be elevated above the others by experiment. The notion of a single moment shared by the entire universe has no operational meaning. This absence has consequences. If no clock can define the present, then the present cannot be a feature of the universe. It can only be a feature of description. Any attempt to say what is happening now requires choosing a frame. And that choice is arbitrary. Physics refuses to complete that sentence for you. It provides relationships between events, not a declaration of which events are currently real. The equations do not pause at a boundary. They relate the entire structure at once. This is not a philosophical omission. It is a result forced by observation. If a universal clock existed, it would break the symmetry that experiments confirm. Time dilation would be asymmetric. One observer would be objectively correct. No such asymmetry appears. The consequence is unsettling because it undermines a basic assumption about existence. You instinctively divide reality into what has happened, what is happening, and what will happen. Physics offers no place to draw those lines. Instead, it offers world lines, intervals, and invariant relationships. These constructs describe how events are connected, not when they become real. Reality, in this framework, does not arrive. It is arranged. This does not mean that clocks are useless. They remain essential tools, but their authority is local. A clock tells you how much time has elapsed along its path. It does not tell the universe where the present lies. When you look at a distant galaxy, you see it as it was long ago. You know this, yet you still think of yourself as seeing it now. This linguistic habit conceals the deeper truth. There is no shared now to occupy. The absence of a universal clock means that the universe cannot update in unison. There is no global moment at which all events switch from future to past. Any such switch would require a reference frame that nature does not provide. What remains is a structure in which every event has its place, but no event has the privilege of being present in an absolute sense. The feeling that there must be such a privilege comes from within systems that track time locally. The universe does not tell time the way you do. It does not need to. Cosmic time is not absolute. Even cosmology does not rescue a global now. The expansion of the universe provides a convenient time parameter, but it is not fundamental. It depends on chosen coordinates and assumptions of homogeneity. The underlying laws remain indifferent to it. When you learn about the age of the universe, it feels like a definitive statement, a single number counting upward from the Big Bang to the present moment. This framing suggests a cosmic clock, ticking uniformly everywhere. But this picture is a simplification, not a feature of reality itself. Cosmological models often use a parameter called cosmic time. It labels slices of space-time on which the universe appears statistically uniform. These slices are useful. They allow predictions about large-scale structure, element formation, and background radiation. But their usefulness does not make them absolute. Cosmic time exists only because the universe is approximately homogeneous and isotropic at large scales. These symmetries allow a particular coordinate choice that simplifies the equations. Remove or relax those assumptions, and cosmic time loses its special status. Even within this framework, cosmic time is not directly measurable. You cannot carry a clock to the edge of the universe and compare readings. Local clocks follow local paths. Their relation to cosmic time is inferred, not observed. More importantly, the fundamental equations of general relativity do not require cosmic time. They describe how space-time curves in response to energy and momentum. Solutions may admit a convenient time parameter, but the theory itself does not privilege one. This matters because it shows that even at the largest scales, the universe does not supply a master timeline. The apparent global history is a coordinate-dependent description layered on top of a deeper structure. different observers, moving differently through the expanding universe, will slice space-time differently. Their notions of what is happening at the same cosmic time will diverge at sufficient precision. No observation selects one slicing as the true present. The Big Bang itself is often imagined as a moment when everything began. In space-time terms, it is not a moment, but a boundary. It is a region where known physics breaks down. Asking what time it was then assumes a framework that ceases to apply. Similarly, saying the universe is a certain number of years old assumes a particular foliation of space-time. That foliation is practical, not fundamental. It works because the universe is smooth enough on average. It is not enforced by law. If cosmic time were fundamental, it would impose a universal ordering on all events. But relativistic effects persist even on cosmological scales. Time dilation and relativity of simultaneity do not vanish in the limit of large distances. This undermines the idea that the universe grows older in a single, shared sense. What grows is the scale factor in certain models, not the universe's participation in a present moment. From within the universe, you inherit this ambiguity. You speak of now as if it were global, because your environment is locally synchronized. Light travel times are short. Relative motions are small. The approximation holds well enough to feel absolute. But approximation is not identity. Physics distinguishes sharply between what is exact and what merely works under limited conditions. The present belongs to the second category. The unsettling implication is that even the cosmos does not age the way you do. There is no universal birthday candle being extinguished with each passing second. There are only relations between events, encoded geometrically. Cosmology offers a narrative of evolution, but that narrative is a map, not the territory. The territory remains a four-dimensional structure, indifferent to the stories told within it. Even at the scale of the universe itself, there is no place to stand and declare that this is the moment it truly exists. Observation. Across light cones, you only ever observe the past light cone of your position. Distant galaxies are seen as they were, not as they are. Yet their later states are part of space-time, regardless of your access to them. Observation limits knowledge, not existence. Every signal you receive has a history. Light takes time to travel. Information propagates at finite speed. This means that your view of the universe is unavoidably delayed. The stars overhead are not present objects in any immediate sense. They are records. This is not a technical inconvenience. It is a structural feature of space-time. Each event has a region from which it can receive influence, and a region it can influence in return. These regions are defined by light cones. Everything you can observe lies within the backward cone. Everything you can affect lies within the forward one. The distinction is geometric, not psychological. No amount of improved instrumentation changes it. Faster telescopes do not allow you to see outside your light cone. They only allow you to extract more information from within it. Yet the universe does not stop at that boundary. Events outside your past light cone are not hypothetical. They are simply causally disconnected from you at that moment. Their existence does not wait for your observation. When you look at a distant galaxy, you are seeing it millions or billions of years ago. You know that it has since changed. Stars have formed and died. Structures have evolved. These later events are not hidden futures. They are inaccessible presents relative to you. This creates a tension with everyday intuition. You tend to treat what you see as what exists. Physics makes a sharper distinction. Seeing is an interaction constrained by geometry. Existence is not. If the present were a global feature, observation might track it. But observation consistently fails to align with any such notion. What you observe depends on where you are and when you are, not on what is currently real. From the block perspective, this is expected. All events occupy their places. Light simply traces connections between them. Observation is a path through space-time, not a spotlight revealing what has just come into being. This reframes the meaning of distance. A distant object is not merely far away in space. It is also separated in time. You do not share a present with it in any absolute sense. You intersect its history. The same applies locally, though the effect is negligible. Even the wall in front of you is seen slightly in the past. The delay is small, but it is never zero. There is no observation without latency. This undermines the idea that the universe reveals itself moment by moment. It does not reveal itself at all. It interacts. The interactions you participate in are constrained slices of a larger structure. Importantly, nothing in this picture suggests incompleteness. The unobserved regions are not waiting. They are simply elsewhere. Your inability to access them does not diminish their reality. This is often misunderstood as philosophical abstraction. It is not. Particle physics experiments rely on the same logic. Detectors register events after they occur. Correlations are reconstructed across space-time intervals. No part of the analysis assumes a privileged now. Even causation respects these limits. You cannot influence events outside your future light cone. But those events do not depend on your influence to exist. They have their own causal networks. The unsettling implication is that your perspective is radically local. What feels like the universe unfolding around you is a narrow causal cross-section. The rest of space-time remains intact, whether or not you ever encounter it. When physics says the future exists, it does not mean you can see it. It means that existence is not gated by observation. The universe does not become real as light reaches your eyes. You live inside a light cone, not at the center of reality. The future as a measured requirement. If relativity is correct, then events that you call future must exist to maintain consistency across frames. Removing them breaks the symmetry that measurements confirm. The future is not added later. It is already required by the structure. Relativity does more than describe how clocks behave. It constrains what can be said to exist without contradiction. When observers in relative motion disagree about the order of events, the disagreement is not a flaw in measurement. It is a consequence of space-time geometry. Consider two events that are space-like separated. For one observer, event A occurs before event B. For another, B occurs before A. Both descriptions are equally valid. Both are supported by the same underlying physics. No experiment can determine which ordering is correct. This creates a problem for any model in which only the present is real. If reality updates slice by slice, then each observer would require a different set of real events at the same time. There would be no consistent account of what exists. To preserve consistency, the structure must already contain all events. The past, present, and future cannot be brought into existence by observational motion. They must coexist within the framework that allows different perspectives to align mathematically. This is not an interpretive preference. It is a requirement imposed by the success of relativity. The equations work because they relate complete histories, not because they predict the emergence of new ones. If future events did not exist, then different observers would be forced to disagree about reality itself, not just about descriptions. This would undermine the invariant quantities that experiments repeatedly confirm. Instead, relativity allows observers to disagree about simultaneity while agreeing on structure. This agreement is only possible if the structure is already complete. You may be tempted to imagine that the future exists only in some frames, but not others. This does not resolve the issue. Frames are not physical objects. They are coordinate choices. Existence cannot depend on a choice of description. the measured symmetry of the laws demands that no frame be privileged. If one observer's present were more real than another's, the symmetry would be broken. No such breaking is observed. This forces a conclusion that feels disproportionate to the evidence. From modest measurements of time, dilation, and length contraction, a radical implication follows. The future cannot be something that comes into being. It must already be there. The discomfort arises because this implication is not directly measured. No instrument detects the future, but instruments detect the symmetries that require it. Physics often works this way. You do not observe space-time curvature directly. You infer it from motion. You do not observe fields. You infer them from forces. In the same way, you do not observe the future. You infer its existence from consistency. This does not mean that future events influence the present. Causality remains intact. Light cones still constrain influence. What exists does not dictate what affects what. The structure contains all events, but relationships within it determine which can interact. The presence of a future event does not allow it to act backward. Geometry enforces order without flow. The idea that the future is required rather than optional reframes your sense of anticipation. What you call the future is not an empty region waiting to be filled. It is a region you have not yet encountered. This does not trivialize uncertainty. From your position, outcomes are unknown. But unknown does not mean non-existent. The distinction is epistemic, not ontological. Relativity leaves no room for a universe that grows by acquiring new moments. Such growth would need a boundary that all observers agree upon. No such boundary can be defined. The universe, as described by successful physics, is not incomplete ahead of you. It is complete in a way that allows you to experience incompleteness. The future is not a possibility space waiting to collapse. It is a requirement embedded in the measurements you already trust. No signal announces. Becoming nothing signals the transition from unreal to real. There is no boundary surface sweeping through space-time. No energy is released when a moment becomes present. The absence of such a signal is itself an observation. If time truly flowed, it would leave a trace. A process that updates reality would require a mechanism. That mechanism would need to operate somewhere, do something, and have measurable consequences. Physics is precise about such things. When change occurs, it is described by interactions, exchanges, gradients, or fields. No such feature appears for becoming. There is no equation term that activates when an event turns real. no detector has ever registered a moment arriving. Experiments sensitive enough to measure quantum fluctuations and gravitational waves find nothing resembling a temporal front. This absence is not due to insufficient technology. It is structural. The theories that successfully describe nature do not include a variable that tracks reality's progression. They relate events across space-time without invoking a current state. If the present were advancing, it would need to advance relative to something. That reference would define a direction and a rate. Neither appears. Time dilation changes clock rates relative to motion and gravity, but it does not reveal a universal advance. Consider energy conservation. If moments were being added to the universe, the total content of space-time would increase. This would require a source. No such source is observed. The universe does not accumulate reality as time passes. You might imagine becoming as costless, leaving no energetic footprint. But physics does not permit costless processes without symmetry justification. When something happens everywhere, all at once, it must respect invariances. No such invariance supports becoming. Instead, what you observe are stable relationships. Fields evolve according to equations that apply everywhere. Particles interact locally. Causes and effects are linked by geometry. Nothing in this web suggests an external clock advancing the universe. Even in cosmology, where expansion gives the impression of unfolding, no moment is singled out as newly real. The equations describe relationships between slices, not the creation of slices. If becoming were real, it would break time symmetry at a fundamental level. Yet, most physical laws are time symmetric. They do not distinguish past from future. The asymmetries you observe arise from boundary conditions, not from a moving present. This matters because it rules out a common escape. One might argue that becoming is too subtle to detect. But subtlety does not exempt a process from leaving consequences. The complete lack of evidence is itself evidence of absence. Physics is comfortable asserting the existence of unseen entities when they are required. Dark matter is inferred from gravitational effects. Neutrinos were inferred before detection. The present as a moving boundary is not inferred because it explains nothing. All observed phenomena remain intact without it. Relativity, quantum theory, thermodynamics, and cosmology function without invoking becoming. Adding it introduces redundancy without predictive gain. This leaves a gap between experience and description. You feel time passing, but nothing passes in the equations. This gap is not ignored, It is acknowledged and localized. The passage you feel is explained by internal change. Systems record, update, and respond. These changes are real and measurable, but they occur within space-time, not to it. The distinction is subtle but decisive. Events change relative to one another. Space-time does not change by acquiring events. The universe does not move from one configuration to the next. It contains all configurations connected by relations. The absence of a signal announcing becoming is not a failure of physics to notice something obvious. It is a confirmation that what feels obvious may not be fundamental. Nothing ever announces that now has arrived. There is no moment when the universe acknowledges itself. Reality does not check the time. What exists does not wait to exist. Time without privilege. Every moment is equally valid in the equations. None is marked as special. The present does not appear as a feature to be detected. If it exists, it does so only within perception, not within the measured universe. Physics is explicit about what it treats as real. Real quantities appear in equations. They influence outcomes. They can be measured, inferred, or constrained. Time, in this sense, is real only as a coordinate. It labels relationships between events. It does not confer status. When physicists write down the laws governing motion, fields, or interactions, they do not single out a moment as exceptional. The equations apply across the entire domain. Replace one time, coordinate with another, and the form remains unchanged. This symmetry is not accidental. It is foundational. If the present were privileged, it would have to break this symmetry. The laws would need to behave differently at one moment than at others. No such behavior is observed. Every tested law treats all moments the same way. This is difficult to reconcile with experience. You feel located in time. You feel as though this moment is more real than others. But physics does not validate that feeling. It does not deny it either. It simply does not recognize it as fundamental. The universe described by equations has no highlighted slice. There is no parameter that says this is happening now. There is only relation. Before, after, between, separated by intervals. This lack of privilege extends even to initial conditions. The early universe is not treated as a moment of special reality. It is treated as a boundary condition for certain models. Its role is mathematical, not ontological. Later moments are not treated as more complete. Earlier moments are not treated as less real. The equations do not describe a universe that matures into existence. They describe one that is defined throughout. This neutrality is not philosophical restraint. It is enforced by consistency. Any attempt to privilege the present would require redefining the laws to behave differently depending on where you place yourself in time. That redefinition would introduce contradictions between observers. The absence of privilege also explains why attempts to measure the present always fail. You can measure durations. You can measure rates. You can measure correlations between clocks. But you cannot measure now. There is nothing to measure. Instruments respond to interactions. An interaction occurs at a coordinate. The instrument records it. At no point does the instrument detect that the interaction is present rather than past or future. That distinction is applied afterward by interpretation. This means the present is not something you detect. It is something you assume. The assumption is useful for organizing experience, but it has no counterpart in the underlying description. From the block perspective, this is expected. If all moments exist, none requires emphasis. Emphasis arises only within subsystems that process information sequentially. Your perception privileges one moment because your cognitive architecture is built that way. It integrates signals over a short interval and treats that integration as immediate. The immediacy is functional, not fundamental. Different organisms or artificial systems could have different integration windows. Their sense of the present would differ. Physics would remain unchanged. This exposes an uncomfortable asymmetry. You trust your perception to reveal reality. Yet the deepest descriptions of reality omit its most vivid feature. The omission is not an oversight. It is systematic. Time without privilege means that existence does not depend on arrival. Events do not wait their turn. They are not queued behind the present. They are arranged. The present, then, is not where reality happens. It is where you happen. The universe does not converge on you. You occupy a location within it. This does not make experience illusory. It makes it local. The laws do not deny what you feel. They decline to elevate it. What physics offers instead is a universe in which every moment stands on equal footing, whether or not it is experienced. Nothing in the structure asks which time it is. The unsettling conclusion is quiet. If the present exists, it exists only as a condition of perception. The universe itself does not acknowledge it at all. Measurement confirms the static whole. Every test of relativistic physics reinforces this view. From particle accelerators to astrophysical observations, the predictions assume a fixed space-time. The agreement between theory and measurement leaves little room for an evolving present. Relativity is not an abstract framework supported by a handful of experiments. It is embedded in daily technology and extreme environments alike. Its predictions are confirmed wherever precision is high enough to test them. In every case, the calculations treat space-time as a complete structure, not as something that updates. Particle accelerators provide a clear example. When particles are pushed close to the speed of light, their lifetimes increase exactly as predicted by time dilation. The equations do not describe the particles as existing in a moment that advances. They describe entire world lines with invariant intervals. The measurements match. Muon decay experiments confirm the same effect. Muons created in the upper atmosphere should decay before reaching the ground if time flowed universally. They do not. Their internal clocks tick differently along their paths. The explanation does not involve a moving present. It involves geometry. Astrophysical observations extend this confirmation across billions of years. Light from distant supernovae arrives with time delays consistent with relativistic expansion. Gravitational lensing bends paths exactly as space-time curvature predicts. The models assume events fixed in space-time, related by light cones. No correction is ever added for becoming. There is no term that says adjust for the present. If such a term existed, it would accumulate error. Over cosmic distances, even a small deviation would be measurable. None is found. Global positioning systems offer another test. GPS satellites orbit Earth at high speeds and in weaker gravitational fields. Their clocks tick at different rates than clocks on the ground. Engineers correct for these differences using relativistic formulas. Without those corrections, navigation would drift by kilometers each day. These systems do not synchronize to a universal now. They rely on consistent relationships between clocks moving along different paths. The success of the system depends on the absence of a privileged present. Even in experiments probing the quantum realm, space-time is treated as fixed. Particle interactions are calculated as scattering events occurring at specific coordinates. Probabilities are assigned to outcomes, not to moments becoming real. If time were evolving globally, quantum field theory would require modification. Fields would need to update across space-time. This would introduce preferred frames or signals. No such modifications are supported by data. Importantly, these confirmations are not isolated. They reinforce one another. The same geometric assumptions explain time dilation, length contraction, simultaneity breakdown, and gravitational effects. Removing the block structure would require rewriting the theory from the ground up. Yet no anomaly demands such rewriting. Where predictions fail, they fail for reasons unrelated to time's flow. They fail at singularities or at untested energy scales. The absence of a present is not among the problems. This creates a strong asymmetry between experience and evidence. Experience insists on flow. Evidence insists on structure. Physics sides with evidence. The static whole is not static in the everyday sense. Events differ across it. Processes occur within it, but the whole does not change by adding events. It contains all change internally. Measurements do not just tolerate this picture, they require it. Attempting to model reality as evolving introduces inconsistencies that measurements do not support. This does not mean that future theories cannot revise the picture, but any revision must recover the block structure where it is tested. The burden of evidence lies with becoming, not with stasis. So far, becoming has left no trace. No experiment demands it. No observation hints at it. The universe behaves as though all events are already there, arranged in a four-dimensional structure. The quiet conclusion is not philosophical. It is empirical. Every successful test of relativity confirms a universe that does not update. What changes is not the universe, but where you are within it. The cost of consistency. To reject this picture, you would need a new theory that preserves all confirmed results while restoring objective becoming. No such theory currently exists. The cost of insistency is accepting a universe that does not align with experience. Physics has overturned intuition before. It did so when Earth lost its central position. It did so when simultaneity dissolved. Each time, the resistance was not technical, but psychological. The equations were clear. The discomfort came later. Here, the situation is similar. You are not being asked to abandon evidence. You are being asked to accept where the evidence leads. If you want time to flow in an objective sense, you must add something to the theory. And whatever you add must not disturb what already works. That requirement is severe. Relativity is not fragile. Its predictions are intertwined. Altering one aspect affects many others. A theory that reintroduces a moving present would need to explain why no experiment detects it, why no symmetry is broken, and why all existing measurements remain unchanged. Such a theory would need to explain how becoming occurs without leaving traces. It would need to specify a mechanism that selects a present without defining a preferred frame. It would need to do all of this while remaining mathematically consistent and empirically silent. So far, no proposal meets these conditions. Attempts to restore objective flow either conflict with relativity or retreat into metaphysics, adding elements that cannot be tested. Physics, as a discipline, does not accept additions that explain nothing measurable. This does not mean that future theories are impossible. It means that consistency has a cost. The cost is relinquishing assumptions that feel obvious but have no experimental support. The present is one such assumption. It feels indispensable, yet it does no explanatory work. Removing it simplifies the theory without reducing predictive power. This is not a failure of imagination. It is a constraint imposed by data. You may object that experience should count as evidence. After all, the passage of time feels undeniable. But physics distinguishes between phenomena and interpretations. It explains why the feeling exists without elevating it to a fundamental principle. The cost of consistency is accepting that experience is not a guide to ontology. It is a guide to survival. The brain constructs models that are useful, not necessarily accurate at the deepest level. This realization is not unique to time. Color, solidity, and continuity are also constructed. Physics describes wavelengths, forces, and interactions. Experience adds texture. The mistake is assuming the texture is primary. Here, the texture is temporal flow. The structure beneath it does not include it. Insisting that it must be included because it feels real is a reversal of method. Physics proceeds from measurement to theory, not from intuition to law. The resistance persists because the implication is personal. Accepting a static space-time feels like losing something essential. It feels as though the future is taken away. But nothing is taken away. What changes is the framing. The future is not removed. It is relocated from an unfolding process to a fixed structure. Uncertainty remains. Decisions remain. Experience remains. What disappears is the idea that the universe is waiting, that it is incomplete until you arrive, that time itself is moving on your behalf. Consistency demands giving that up. The reward is coherence, a description of reality that does not contradict itself across frames, scales, or measurements. This trade is not optional if you accept the data. You can reject the picture, but only by rejecting the framework that produced every successful prediction about time to date. Physics offers no compromise position. Either the equations are correct or they are not. If they are, then the universe they describe does not privilege the present. The cost is psychological, not scientific. The universe does not adapt to how it feels to you. It remains consistent regardless. Accepting that consistency means accepting a reality that no longer centers experience. Time does not bend to intuition. It remains what measurement requires it to be. And that requirement is already met, everywhere, all at once. Living inside a completed structure. You are located at a specific region of space-time. Your thoughts, actions, and uncertainties are part of that region. The rest of the structure does not wait for you. It does not respond to your sense of now. This placement is not metaphorical. In physics, every process occupies coordinates. Your body traces a world line. Your brain activity corresponds to physical events distributed along that line. Each decision, each sensation, each moment of doubt is an event with a location. From within that region, the universe appears to unfold. Signals arrive. States update. Memories accumulate. This creates the impression that the world is advancing toward you. But what is advancing is information, not existence. The rest of space-time is not frozen in anticipation. Distant events are not paused until you observe them. They are simply elsewhere. Their relationship to you is defined by geometry, not by readiness. This perspective removes an implicit assumption. You often imagine yourself at the edge of time, with the future extending ahead as possibility. Physics places you inside time, embedded among other events that do not depend on your position. Your uncertainties are real. At your location, outcomes are not known. Competing possibilities are represented internally. But these uncertainties do not imply that the universe is undecided. They reflect limits in access, not limits in existence. This distinction matters because it separates experience from structure. The structure contains all events. Experience samples them sequentially along a path. The sampling feels like motion because it is constrained by causality. Within this structure, nothing has to wait for anything else to become real. Events are not queued behind the present. They are arranged relative to one another by invariant intervals. You might imagine that if the future exists, it must exert some influence. But influence is not a consequence of existence alone. It requires causal connection. Light cones enforce that connection. They limit what can affect what, regardless of what exists. This is why the future does not determine the present, even if it exists. Causality remains local. The block structure contains the rules that prevent contradictions. Living inside a completed structure does not feel complete. From your perspective, the path ahead is unknown. This ignorance is not illusory. It is a physical condition of being embedded in space-time. At any given point, your past light cone contains records. Your future light cone contains possibilities. These are descriptions of access, not of reality's status. The discomfort comes from conflating the two. You want the universe to mirror your perspective, but physics consistently shows that perspective is limited. This limitation does not diminish meaning. It changes its source. Meaning arises from relationships within the structure, not from the structure unfolding. Your actions matter because they are part of the structure. They connect to other events. They shape outcomes within causal limits. They do not need the future to be open in order to have significance. The completed structure does not imply resignation. It implies placement. You are not outside time looking in. You are inside it, contributing to its form. This reframing removes the sense that the universe is progressing toward an end. There is no finish line being approached. There is only the totality of events, arranged. From within that totality, you experience urgency. Deadlines feel real. Consequences feel imminent. These feelings are accurate at your location. They do not describe the universe as a whole. Living inside a completed structure means accepting that your sense of now is not a cosmic signal. It is a local condition, arising from how information reaches you. The universe does not synchronize to your awareness. It contains the process by which awareness occurs. You are not watching time happen. You are where time happens to you. The unsettled implication. If the future already exists, then your passage through time is not a traversal of reality, but a pattern within it. The universe does not unfold. It simply is. What remains unresolved is not whether this model works, but why a static structure gives rise to the feeling that something is still happening. The success of the block model leaves little ambiguity at the level of description. It accounts for every confirmed relativistic effect. It preserves consistency across frames. It requires no hidden mechanisms. As a physical model, it functions without contradiction. What it does not explain is experience in the ways experience explains itself. You do not feel like a static pattern. You feel like something in motion. Moments appear to arrive, occupy awareness, and then recede. This sequence feels fundamental. Physics does not deny that this feeling exists. It identifies where it does not originate. the feeling does not arise from the structure of space-time itself. The structure contains no marker of arrival or departure. It contains only relationships. This places the source of temporal experience entirely inside certain regions of the universe. Systems that process information sequentially generate internal models of change. These models compress causal structure into narratives. The narratives feel like flow. Yet the explanatory gap remains. You can describe the mechanisms that store memory and compare states. You can trace how neural processes generate continuity. But none of this captures why the sensation feels the way it does. Why does the internal comparison of records produce the impression of movement rather than coexistence? Why does awareness privilege one region and treat others as no longer real? These questions persist even when the physical description is complete. The block model explains time without explaining now. It explains change without explaining passage. It describes what happens without capturing how it feels to happen. This is not a failure of physics in the usual sense. Physics was never designed to explain subjective experience. It explains relations between events, not the texture of awareness. But here, the gap matters more. The feature left unexplained is the one that feels most central. The universe can be described as static, yet nothing in experience feels static. This tension does not point to an error in the model. It points to a mismatch between levels of description. The universe does not include feeling. Feeling includes the universe. You are left with two accounts that do not contradict each other, yet do not meet. One describes a complete space-time. The other describes a moving present. Only one appears in equations. The unresolved implication is not that the future exists. That follows from consistency. The unresolved implication is that your sense of becoming is not a feature of reality, yet it dominates perception. There is no evidence that this feeling corresponds to a hidden variable or an undiscovered field. There is no sign that a deeper theory will restore flow. If anything, deeper theories remove more structure, not less. This suggests that the sensation of passage may be irreducible, not fundamental in physics, but fundamental to experience. A feature of how certain systems exist within a static whole. The universe does not progress. You do. But that progress is not movement through time. It is a sequence of internal states arranged along a world line. This is difficult to accept because it reframes what it means to be present. You are not at the edge of reality. You are inside it, experiencing one cross-section at a time. Nothing in physics promises comfort here. The model does not soften the conclusion. It does not offer a resolution in which both intuition and measurement are fully satisfied. The universe works. The equations hold. The predictions succeed. The cost is accepting that the most immediate aspect of existence does not appear in the deepest description of it. What remains is an open question, not about physics, but about why experience feels temporal at all. Why a static structure supports a moving viewpoint. That question has no settled answer. It is not resolved by more data. It lingers because the model is complete without it. The universe does not wait. It does not change. It does not advance. And yet, from where you are, something keeps happening.